Hey, look at this, they gave me another LED and a capacitor with this. So for a long time now I've been waiting for an update for this component tester. I covered this in a previous video and I was really pleased with it, and frankly I'm using it almost every day in my daily job. And now it seems like for a few months now the T7 came around, and this is a more evolved model, and it's supposed to be able to measure thyristors, all sorts of MOSFETs including IGBTs, triacs and Zener diodes. So let's see how it's behaving like. So like any other tester, like any other component tester of this type, it has this start button. It goes through self-test and battery voltage test, and then it should be testing the component which is inserted here. A major plus in my opinion is that it has this fancy display. It has this component socket already labeled here. This was an issue with this T4. Another cool feature about this is that it has an internal lithium-ion cell. This battery is charged externally using this micro USB cable, which is supposed to connect here. Red light when it's charging and green light when it's completely charged. I have all sorts of components here I want to test: a triac, a diac, Thyristor, Zener diode, switching diode, bipolar junction transistor. So let's see how they behave. So if I insert it here, press the button, it will display the beta parameter of the transistor, the opening threshold voltage, so the base emitter voltage. It will display a picture with the symbol of the component, which is really helpful because you can tell right away what type of component is, and it will also display which terminal is which, and it will say here in the subtitle what type of component is. If I connect an inductor here, so this is a 33 microhenry inductor, it will give me an approximate value. As you can see, like for the T4 component tester, it doesn't have enough digits to show low inductor values. When you test an LED, it will flash the LED a few times, and then it will display the symbol of the LED, the forward voltage of the diode, and the internal capacitance. I was really surprised to see when I am connecting, for instance, an LED here in the Zener diode area. If I connect it in reverse, it will recognize it as being a Zener diode, and it will display like 16 volts reverse breakdown voltage. I didn't quite believe it at first, because I went through the datasheet of the LED and it says nothing about a reverse breakdown voltage of about 16 volts. But then I did the following experiment. I took this 5mm square LED and connected to my power supply in reverse. I set the current limit to about 5 milliamps, and I gradually increased the voltage, and when I reached about 15.9 volts it started breaking off and allowing current through the junction, and I could see that the current was increasing to what I set the limit to, that being 5 milliamps. So hey, there you go, you have an LED that behaves like a Zener diode. Okay, enough with the LEDs. Let's see how a MOSFET is behaving. This is supposed to be a very low internal resistance RDS on resistance MOSFET, and let us see what it's saying. It displayed the RDS on being about 0.2 ohms, and that is 200 milliohms. The data sheet of this MOSFET is actually saying that it's an 8 milliohm MOSFET. So this measurement is not really accurate, but I'm still happy about the fact that the component tester is recognizing it as being a MOSFET, displaying all the other parameters, is displaying the symbol of the MOSFET. So I'm really pleased with this function of identifying the components. If I place here a higher current MOSFET, let us see what it's saying. Yeah, so it seems like it really has a problem with this resolution here with the RDS on. This is not really precise diode. Let's see what it says with the diode. Displays the forward voltage, the pins, a Zener diode. So I'm supposed to connect this diode here, and with the cathode on that end on the left, and with the anode on the right. Yeah, and it displays the actual voltage of the diode. Looking into the datasheet of this diode, it says that it's supposed to be an 11.5 volts diode, and this thing is displaying about 12.5, so I don't think it's really accurate. This is how a PNP transistor is being identified like. And my biggest curiosity would be to measure a triac or a Thyristor and see what is displaying. Takes a while. Yeah, there you go. So this is supposed to be a Thyristor, and it is recognizing it as being a bipolar junction transistor. Yeah, another MOSFET. Oh, and this is also supposed to tell you what kind of MOSFET is. I mean, the data sheet I downloaded from the internet, it's saying that it is supposed to distinguish between IGBT, JFET, MOSFET, N channel, P channel. But the most frustrating part of all is that it won't tell me if it's a Thyristor or not. I think this is supposed to be a triac, and it is still, yeah, there you go. So the first time I pressed the button, it was showing me that it's a bipolar standard transistor, and now the second time I pressed it, it showed me that it's a triac. So from this point of view, I think it has some problems with, yeah, again with the bipolar junction transistor. It has some problems, yeah, there you go, with recognizing it as a triac. So this can be a little confusing, I can tell you. I think I'm still gonna use this T7 component tester because I kind of like it, and besides the fact that it has these limitations with recognizing triacs and thyristors, it's still a good tester and it's really fast. I mean, compared to other multimeters, I really like this one because I can, when I'm fixing something, I can remove a component from the circuit, from the motherboard, insert it into this thing, click the button, and it will tell me right away if it's a good component or a bad component, or what kind of component is, and it will just give me so much information instantaneously. I am inviting you to click the subscribe button to support this channel. Of course, like this video, and if you want to see more videos like this one, go to my channel and you have more videos with reviews and some other technical things there. Thanks for watching.